get a chance to work together a little more. But before we do that, we're actually going to get to our presenters. So before we begin, just like to remind everyone that this session will be recorded and you can check it out later on civictech.ca. It's courtesy of Charlie, so thank you, Charlie, for recording this and live streaming this. But if you have any problems with this, or you think you're going to be in the video and you have issues with that, then please feel free to get in touch with Charlie right here in the front. And now I'm going to actually introduce our presenters. So the first one is Jeremy. He's a technology specialist at BAI Canada, where he helps operate and maintain the wireless network BAI Canada has deployed throughout Toronto's transit system. Jeremy will be sharing his insights into the challenges and triumphs of BAI's TCONNECT, Wi-Fi and cellular rollout, as well as speak to the future of BAI's Civic modernization initiatives, leveraging their unique communications infrastructure for multi-tenancy connectivity. He also manages an exclusive contract with the TTC to deploy and operate the wireless communications network throughout the underground TTC subway system. He really also wanted everyone in this room to know, if you ever go to the Artful Dodger, he's also a DJ. He tells me that he drops exclusively 90s hip-hop sets, which prior to this presentation he informed me was, quote-unquote, turned. And he informed me it's a lot of Mariah Carey and Puff Daddy pre-Sean John. I confirmed this with him. And then there is his presentation co-presenter, this Michelle, who is a marketer at BAI Canada. She informs me that you should go to Jeremy's DJ shows because she has a great time and she dances a lot there. But she is also, in her words, the voice of TCONNECT. So I'll leave it. So welcome them both and give them both a warm round of applause.
We switch it over? You can probably tell from my haircut that I don't do a lot of public speaking. So I actually Googled some tips before this, and they said, make sure you tell the crowd that it won't be long. That way, no matter how bad it is, everyone knows it'll be over soon. So this won't be long. And in fact, I'm going to try to sort of rush through the presentation and get to the questions. That way we can focus on the sort of things that interest you guys. So BAI Canada. So first I'll tell you who I am. I'm Jeremy Foran. I come from an internet on trains background. So I've worked with Via Rail and Amtrak delivering connectivity to moving stock, rolling trains. I got involved with BAI about 2 or 3 years ago as a consultant and came onto the team about a year ago and have been working to bring Wi-Fi connectivity to the Toronto subway system. So who is BAI? We belong to BAI Communications. We're a subsidiary of them, but we are 100% Canadian owned. And BAI Communication focuses on bringing RF connectivity throughout the world. So that's broadcast, Wi-Fi, cellular, digital, all those different forms of RF media. So we have a sister company in New York called Transit Wireless who has almost the exact same business model of us, which is deploying fiber optic networks and providing connectivity in subway stations. So I don't know if I covered that, but that's what we do. We provide connectivity in the Toronto subway system. So Broadcast Australia, which is part of BAI Communications, they provide broadcasting services in all of Australia. I read that it was 1,500 services are provided to 99% of the population, which leads me to believe there's like one guy who won't put an antenna on his TV. Right? Tough crowd. So how this business works is by laying fiber where it's difficult to do. So if you could imagine trying to run fiber in New York or Toronto, there's a lot of challenges with that. Providing it in subway systems It has a really good footprint typically. It usually covers the urban area. And if you can imagine, you typically want to run fiber through a pipe. Well, the subway is a very big pipe. So once you have that fiber laid, it's about the different services that you can then provide, public-facing Wi-Fi being one of them. So when it comes to building Wi-Fi networks in subway systems, there's a lot of challenges. Don't know where to get started with the challenges. All these challenges are things we deal with all the time. So right off the bat, when you design Wi-Fi networks, there's this idea of a small, medium, and large network. And a small being like the Wi-Fi you have at home, and a large being like the football stadium. A football stadium in Wi-Fi is sort of considered the biggest. And that's designed to support 40 to 80,000 people. When you have a subway system, you have, with 1.6 million riders coming through, you have roughly about a football stadium every hour. And depending on peak usage times, that's every 15 minutes. So designing these RF networks, the equipment's not really manufactured to do those sort of things. You require a lot of tweaking. Your back-end services aren't really ready to handle that load of traffic. There's a lot of things that have to be customized and optimized for this sort of delivery. So it's pretty challenging. And then on top of that, there's things that are particular to each subway system. For example, in Toronto, we're currently restricted to the 2.4 gigahertz radio. Now, all that means is that there's a lot of channels in which to move traffic, and we're restricted to 3, right? So it requires a lot of specialized tuning by our RF team and that sort of stuff. The other thing is the actual hardware they manufacture is designed for around 70 people. So when you want to add more capacity, you have to add more hardware. Well, at a certain point, you start having all these different radios broadcasting to support more people. They start interfering with each other, causing RF interference, noise level. So it's like a balancing act, and it's really quite challenging. Next slide. Okay, so I want to have an example of how these challenges come up all the time, constantly. We are an ad-sponsored Wi-Fi service, which means you don't pay for it, you just see an advertisement on our captive portal. And the more revenue that we can generate for this, the better, right? We're able to, buy newer equipment at a higher frequency and that kind of stuff. So we did a deal. So this is going to take a minute for me to explain, but I promise it's going to be worth it. So we did a deal with this company to provide interactive advertisements. So you grab the condiment and throw it on the burger. You have to drag it across. And when we talked to them, we said, hey, we've got a lot of users on our network. Are you sure you're going to be ready? And they said, don't worry, we do this. This is our business. It'll be fine. So they also have fraud detection, which is very important in digital advertisements. That fraud detection system wasn't really ready for the kind of traffic we saw. And what it does to try and combat that is it has a CAPTCHA. Now, for anyone who doesn't know what a CAPTCHA is, if you ever try to buy concert tickets, it's the I am not a robot, type in here so I can prove you're a human, all that kind of stuff. Well, the CAPTCHA kicked in, and at around 6 in the morning, this is what people started to see for the Wi-Fi. Pretty challenging, right? At 6:15, the intensity got higher. And the way they wrote this is they never expected to see fraudulent behavior continue from the same network. So it just went on. By like 6:45, it's come off the rails, right? At 7 o'clock, it's just, I can't discern a single letter from that. Then it just went silent. The algorithm decided that it needed some time on its own. And then when it came back online, it was even harder to understand. That last slide I actually made up. That's not a real. But it felt like that. So there's just And when you talk to these companies, they're like, we've never seen traffic like that before. So it's always just about these special considerations you have to make when dealing with bringing Wi-Fi to subway riders. But our biggest challenge. So in this model we're using in Toronto is based pretty heavily off the success they've had in New York. So they built out this system in New York, they have these business models where they're generating revenue, and it becomes like a feasible business. It becomes something that we try and iterate in different parts of the world, right? That was based on carrier sign-in. So with this fiber optic network, we deployed what's called a DAS system, or a distributed antenna array. That's a really fancy way of saying we put in equipment to enable carriers to provide cellular service in the subway, so that if you're talking on your phone, you get down to the station, you can continue, where normally you wouldn't be able to do that. So we based our approach, or our model, off the same approach as New York. And we've been having some challenges getting some sign-in from all the carriers. Currently, we're super thrilled to have Freedom Mobile, and we built the system so that all the carriers could come online. In fact, I've seen some people tweet about Freedom Mobile, about how good the service is inside the subway station, right? So we're working towards that. So growth in the IT space. This is about, now that we have this fiber optic network laid out in a big footprint of the city, what are some of the advantages or the partnerships we can foster to leverage it? So when Presto came along, the TTC was trying to do a modernization program of updating how riders use the service, the quality of the service, all those sort of things. Presto started rolling out their own network. And at the time, we were already deploying ours, and it was simple to say, hey, why don't you guys, instead of building duplicate network and infrastructure, just piggyback on what we already have available, and then we'll expedite your rollout. So we tweaked our schedule to align closer to theirs, and it was a big success. They were able to provide connectivity for all their different payment systems, all through our backbone, right? So it was pretty simple. Just wire up our data center, carve out some VLANs, and all their stations are connected. Union Station, I don't know if anyone's been down to Union Station lately, but they're doing some big renovations. They're turning it into sort of like a community area with a lot of different shops and marketplaces, right? We were able to provide some connectivity options, which were fairly limited there because it's a historic building site, and we were able to offer them Wi-Fi connected services for rebranding for their customers. So if you went there, you might see something from, I'm not too familiar with this project, but Jamba Juice? Jamba Juice? Booster Juice? So we were able to rebrand. Even when you go down there and there's the TTC Union Wi-Fi, we're actually providing those AAA services and splash page so that you can get on. If anyone has seen this, right? So when Pattison One Stop was providing this information, it pulls from their central media server and delivers this over a link. Each station had like a different connectivity method. Some were on DSL, some were on dial-up, some were on cellular connectivity, right? We were able to extend them wireless coverage and VLAN DIM services so that they could connect all of their stations with high-speed internet. And then also we have our base station hotel, which is the data center for all this connectivity. They were able to do things like take their video streaming services, which require deploying equipment in the subway, and potentially move that into our base station hotel where it's air conditioned, cooled, security, all that sort of stuff. Get away from brake dust. So it was like a no-brainer. Civic monitor, okay, looking for the future. So this is what keeps me up at night, thinking about what we can do with the infrastructure, specifically data. So I believe that we have, we're able to do some things that are pretty unique. So when you start to look at the Wi-Fi data and how people associate, you can start to tease out patterns. An example would be if you look at people, how they connect in the morning. Well, typically somebody will get into the station, they'll pull out their phone, and they'll connect until they get on to the train. The frequency of those trains is every 2 to 3 minutes, depending on the station. If somebody's phone is associated for longer than 2 minutes, let's say 4 minutes, 5 minutes, 6 minutes, it probably means that train is full. So if we look at the aggregate of how many people's phones are in the station at a greater frequency of the trains coming by, we can start to figure out, well, the train was full here, and we can back it up to figure out when that happened. And then you can start marrying that up to weather information to see, well, what effect did weather have, or the day, or maybe other traffic data. So that's sort of what we're starting to look at now. I think I might have jumped ahead here. Wi-Fi on trains, okay. So this is where I come from, Wi-Fi on trains. Providing connectivity so that the users can more or less be entertained while they're on the train. If people have things to do, they'll typically be more gracious or appreciative of the service overall. They'll let some things slide, right? If a raccoon gets on the train, something like that. But the other piece of that is providing connectivity to a big piece of equipment with a lot of moving parts on it. So when I was doing similar work for a rail operator in the States, we put Wi-Fi on the train, and then we started sending the data back to analyze it and look for patterns. Well, we noticed this one very particular pattern. When the actuator was given a command to shut the door, it would record what time the command was issued and what time it would be completed. If you start to look at it, you can see that starts to lag a bit. And to the point where if it lags beyond a certain amount of time, you can predict within like 90% certainty that that door actuator is going to fail. And if it fails when it's in service, that means delays. And those delays have monetary consequence. So by being able to look at the data and figure out and predict failures, you can resolve them before they happen. So that's what I'm really excited about, is getting connectivity on the train so that we can start looking at that equipment. I ride the train every day. And when you get on in something like the AC, right, you feel that. So, yeah. So this goes back to what I was speaking about before with the improved transit planning, right? I would like to look at the data and see what effect does the Toronto Maple Leafs, winning the Stanley Cup have on the. It'll happen. It won't happen. Anyway, but how we can start to figure out these patterns which may not be apparent, or things that we might have anecdotally assumed which may not be true. Retail and enterprise. So because we have this large fiber optic footprint in the city, it allows us to provide dim services, or dim fiber, dark fiber services, which basically means there's a fiber over here that runs across the city. If you have 2 buildings and you want to connect them, right, we can provide you that connectivity. I feel like there's some other things I'm supposed to say here. Nope, got it all. I didn't put together this PowerPoint, by the way. Michelle did, the voice of TTC. No. Oh, sorry, asset monitoring. So if you look at something like a hospital, it's a very big, very busy building with a lot of assets rolling around. So there'll be times where things need to be located, which is really challenging, right? I don't know anything about hospitals, but I could imagine some sort of like a scanner device on wheels that's supposed to be over here, but it's not, right? What they've started doing is something called asset monitoring or asset tracking, where they'll put a Bluetooth beacon or a Wi-Fi beacon on it, which just has a battery, will run for 5 years, and then somebody can look at how that's broadcasting, triangulate it based on what access points hear it, and know exactly where it is, and then they can see a history of where it went. One of the reasons that might be valuable for rail environments is if you have things as simple as a cart you want to track or equipment. In New York, what they've done, they've taken a novel approach. They've put Bluetooth beacons on the front and the back of the trains. As they hear them, that updates a database which refreshes all the screens. So instead of trying to build some sort of trackside or something that ties into the markers on the tracks, they just put beacons and listen to the signal and leverage the Wi-Fi network they already had in order to accomplish something that probably would have been pretty challenging if you wanted to take a different approach. So right now, if you're in New York, there's letter lines and number lines. One of those two, the signs are updated based on beacons on the train as they roll through the system. Public safety and security. So by having this fiber optic high-speed network deployed, you're able to do things like connect CCTVs, right, and closed caption systems so that you can monitor screens in real time, as opposed to after something has happened, trying to go back and do an investigation afterwards and see what the video shows, that sort of thing. Layered, so I messed something up. This was supposed to be the dim fiber services. Maybe it'll come up in questions, what I missed. Questions? Boom. Yep, right there.
So I just have the thing you mentioned of the fiber optic network to the trains, right? On the subway line. So you must be connected to some gateway somewhere. So are you taking the internet gateway services from the traditional players like Bell Rogers?
We try to use diverse paths. So our fiber optic network is 800 count fiber. We have diverse paths through every station, and then we have multiple data centers. And part of having a resilient network is having multiple gateways. So we have multiple vendors.
Thank you for the information and sharing that with us. I just want to ask you a question regarding the slide you shared with us. That was freedom is a part of the process, right? And but there was a Rogers, Bell, and another carrier. So what it tells, yeah. So what was the point to stop those three biggest telecommunications
Sure.
companies to participate in this project, which is basically an opportunity to show them to the public and leverage their service.
Absolutely. I don't know their decision-making process. I would say call your carrier. But what I can tell you is we built a carrier-agnostic system, right? Sort of like a highway where anyone can get on. Freedom Mobile was the first, right? Hopefully we'll have all of them, but I couldn't tell you why they've currently decided not to have our service. Uh-oh, you have a smile.
I can't help but wonder if they're just used to not working together.
I think if you...
Because I can't see a situation where it's usually always one carrier dominates, like it's always on the belt place, or I don't know. I guess perhaps you can compare it to like like the Toronto airport. What do they use?
So I'm more familiar with Montreal.
Okay.
I used to live in Montreal. That's where Via Rail headquarters was when I was consulting with them.
Okay.
They provide LTE connectivity, so not Wi-Fi, just LTE. Okay. And the three of them came in, I believe, as a consortium. This is all a matter of public record, so you can look it up, and I could be mistaken. But I think typically when their history is to come in together, and I think originally in the RFP they were one of the a consortium of the carriers responding. So
Okay.
that's all I don't think I can provide anymore.
Well, that's interesting. So you have an example of when they work together, so I don't understand why they can't do it together.
Call your carrier.
You see, yeah.
Call your carrier now. Like, one of the things I will say is we built this network, so
I'm
no
not
matter.
saying it's you, I just mean
Sure.
there's already a clear example.
Well, it's not gonna be me.
Yeah.
But what I would say is, you know, no matter what carrier you're on, we built this network, and currently everyone has 911 services. That was the point I missed. Yeah.
Yes.
So there's 911 services, which I believe is required by law when you build these networks. So so that's available, right? But you'll have to call your carrier. Say, tell them Jeremy sent you.
I will. I'm gonna say it. Jeremy wants to know why you won't sign this.
We're gonna fix this in post, right?
So I was wondering, I've used TCONNECT at the stations, but I haven't been able to connect from station to station. Is that in the roadmap?
Yeah. So it's TTC is a partner of ours, and it's very important that we work together. They proposed a phased approach. The first phase being connect all the stations. We're now at 68 of the 69 stations, correct? Yeah, so we're finishing up on that phase, and we're looking to do connectivity on trains, right, which provide Wi-Fi your entire trip. That's the sort of thing I'm excited about, right? So it's very much on our roadmap and what we're working towards.
So for that particular example of the subway, if it cannot use LTE, what would you use, like a...
Oh, such a good question. Okay, so how do you connect a train, right? I happen to believe that putting internet on trains is one of the hardest jobs in the world, and not just because I do it, right? But there's always challenges, and they're not typically just based on technological challenges, right? There's technology to do this. It has more to do with things like the environment, the business model. No one here will pay $50 to check their email, right? But sometimes that's what it costs to deliver connectivity, right? If you look at long trains, right, they have the same modems that you have in your cell phone. So now they're trying to provide Wi-Fi service to 300 people who have 300 devices who are competing for the same resource. And then you need to do things like aggregate, right? And just by aggregating to maintain TCP sessions, you're losing 20% overhead of your data bandwidth. I know this wasn't what you were asking, but these are, like, putting internet on trains is something I really love doing because it's such a challenge, and it's different from rail operator to rail operator. North America, South America, Europe, like, it's always a challenge, and it's hard because people will say, well, they've had this in, you know, like Japan for 20 years, why don't we have it? You know, there's all sorts of things that make up these puzzles, right? So what we would probably do in the TTC is utilize the fiber optic network we have now to provide an optimized version of Wi-Fi that provides high-speed handoff. So you would have an access point on the train that you would connect to. Yeah, you would, I mean, this is a proposal I'm making right now, right? This isn't on paper or anything, but probably the best approach would be to have access points on the train, you connect, and then the train itself then connects to access points in the tunnel, and there's a handoff, right? That's how they do it in some other parts of the world, which is performing really well right now, so, boom.
So I'm cognizant of time, and you'll stick around for more questions before, correct? Or-
Sure.
So before we do that, we just have two last questions. I'm just going to ask that you two just keep it really, really short.
Hopefully it's a short answer. It sounds like a lot of the business model that you're involved in is maximizing the use of the fiber network. And
Absolutely.
How do you go about making the partnerships and connections with other organizations?
We'll just let him ask his question and then you can sort of decide.
Do both?
Yeah.
Okay. I'm gonna pick one.
I was wondering if you can tell me what kind of information would you keep from the user and logging into the network?
Sure. Two different questions. One, how we do partnerships, and the other is protecting the privacy of people joining the network. So first, how we do partnerships. If you're offering something, we'll talk after, right? There's some things that we understand very well, which is civil engineering and deploying fiber optic networks. There's other things which is new to us, which is digital advertising, which I'm starting to learn is very complex. There's a lot of moving parts. So Some of it is, you know, the DIM sales, fiber optic sales. We have a sales team that does that. There's other ways where we're trying to explore new revenue streams. So I gave the example of using machine learning to create models which predict ridership or when a train gets full as it relates to weather, right? I think there's value there. I could be wrong, right? But if you happen to know that there'll be an influx of people, right? Maybe that means the TTC can plan differently, or maybe that means that that some company that is acutely located to that particular subway station might be able to leverage it somehow. So I would say there's just like a lot of room for exploring in partnerships, and we're open to anything. So come on over, right? And then in terms of security, right? So there are some things that, you know, if you were to pick up your phone, at some point you have to dial a number. That's the only way these connections are made, right? So when you associate to their Wi-Fi, this is a layer 1, layer 2, layer 3 connection, right? And we require, we keep some of that information so that I can tweak and perform the network to work better, right? And pieces of things like MAC information gives us insights into what kind of device you have, right? And we can start to tease out things, well, iPhone deals with captive portals or, you know, when you have to accept the terms and conditions, right? They deal with it one way, Android does it another way. Understanding how those relate is very important. And then when I talk about things like machine learning and aggregations, what we typically do is we anonymize any of that data, and then we look at it as aggregates. So I'm not looking at a device, I'm looking at the performance of some GUID, GUID, right? And how they all relate and that sort of stuff. So if you have any particular questions, I am not a lawyer, right? But we have a terms and conditions page which outlines all of the particulars.
All right, so thank you so much, Jeremy. I saw that there were a lot of hands. Unfortunately, we couldn't get to you to ask your questions, but